Alright, gang. Going to finish off Chapter 5. When we last saw, we had been talking about the wrapper classes, talking about the string class. The string class contains, the code to support a series of characters. And then once you have that series of characters, what can you do with it? You can check to see if it's something equals something. You can check to see if it's equals something ignoring the case, whether it's uppercase or lowercase. You can get the length of it. Excuse me. You can get a character at a specific position. So those are all part of the string class, but there's quite a few other methods. So let's go ahead and take a look at what we have. There is one called substring. If you've done Python programming, it's the same thing as string slicing. You say, I want a substring, and I want it to go from this beginning position to this end position. And so if this is 1 and this is 10, it's going to go from character 1 to 9, because this actually specifies 1 after it. If you want the characters 5, 6, and 7, you would put 5 there and 8 here, so that it would get 5, 6, and 7. Yeah, let's make a lecture P. Unlike last time, I really do want it to make the main class. Of course, you know how to make a main class if it doesn't make one. All right, so let's just create a string and check out some of the methods. String s is equal to hello, right? And let's get a longer one. Hello there. So if we want the length of the string, it's just s.length parentheses in parentheses. If this was an array, which we'll do next, you wouldn't put the parentheses here because it's just a property of it. It's an attribute. But here it's a method. All right. What if you wanted to compare it to something? If s.equals goodbye, end quote in parentheses, whatever, then system.out.println, not a goodbye. Now, it's not going to equal that, right? Because obviously it doesn't. We set it equal to hello there. I forgot my parentheses there. Need my 2 parentheses. There we go, right? So there we go. Now, that's not true, right? It's not going to be equal to goodbye, but that's how you would compare it. What if you wanted to compare it, but ignoring case? If s.equals... Can't believe I made that say goodbye. There we go. Hello there, exclamation mark. But I'm going to change it to equals ignore case. S dot equals ignore case, right? System dot out dot println whatever, right? Some kind of success message. Yes, hello. What if we just want the first 5 letters of it? String first equals s dot substring starting at position 0 and going out. I want it to be 5 long, so 0 plus 5 is 5. Why 0? As we discussed previously, it starts counting as 0. The first subscript, the first index is 0. So that's actually index 0 right there, right? That H. And so that's E is 1. That L is 2. That L is 3. And that O is 4. So we put a 5 there so that we'll get everything from 0 to 4. 0, 1, 2, 3, 4. So if we print it out first, we'd see the word hello. How about here? We want these 6. Well, what does it start with? Or 5 if we want to leave off the exclamation point. Well, it's the starting position. Let's figure it out. That's 0, 1, 2, 3, 4, 5. It's starting at 6. And I want 5 characters, so 6 plus 5 is 11. So string the second word is equal to s dot substring starting at 6. And 6 plus 5 is 11. There we go. Right, so now we have those two words. What if we wanted just to know what character was at that position? We would use .char at. I believe that's position 11, because that's 0 right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, okay. So char ch1 is equal to s dot char at position 11. That'll be our exclamation point. If you specify a starting value for a substring, but not an ending value, it goes to the end of the string. So for example, if I specified the comma here and I didn't give a second number, it would equal the entirety of the string. So if I said substring 3, because that's 0 and that's 1 and that's 2, if I said substring 3 and I didn't give any other values, it would go to the end of the string. System.out.println parentheses s dot substring, and let's start at a position 6, right? That's going to get everything including the exclamation point because I did not specify a final value. Start at 6, go to the end. Index of will return the position of the first occurrence of the specified character. What if we want to find the position of the string? Oopsie. What if we want to know where that string is right here? Well, let's make a new string. I'm tired of using hello there. Let's do s is equal to Darth Vader. Right? And we want to find where that space is. So int space is equal to s dot index of, and it erased it after I hit it, index of parentheses quote space quote semicolon. Now this could either be a single character, in which case you could put apostrophes around it, or it could be an entire string. You want to find the position of the word Vader in it, then you could put the entire word Vader there. Yeah, why not? Let's look for VAD. Well, what is that position going to be? The position of the VAD is going to be at 0, 1, 2, 3, 4, 5. It's going to start at position 6. System.out.println. Well, it's no longer a space, is it? Tell you what, let's go ahead and make it a space then, just so to match the number. Space found at index plus space, right? And so indeed, the space was found at index 5. That's position 5. You can also use last index of, which will search from the end. Now what if you look for something that isn't in the string? It will return -1 or a value less than 0. I believe specifically -1. But you can always just check to see if it's -0, less than 0. Some search functions return a value less than 0, but it's not always equal to -1 in order to indicate where it would have been if it had been in the string. That's kind of strange. So let's just go with the official nomenclature that it's equal to -1. So if we look for a comma, there's not going to be a comma in, is there? Int comma equals s dot index of, I did it again, index of parentheses, quote, comma, end quote, in parentheses, semicolon. And if it's less than 0, if comma less than 0 or equals -1, it means it wasn't found. System.out.println no comma found. Which is the case. There's no comma in our string Darth Vader. No comma found. All right. So last index of is identical to index of, except it starts searching at the end of the string rather than the beginning of the string. So formatted output with the printf method. I believe we've done a little bit of this so far. No, I'm not sure that I'm done talking about strings, even if they think they are. We have a string named s dot. Let's look at all this. Concat. You can concatenate it to another string onto it. That's kind of a strange thing to do, but you could just say concat some question marks on it, and then when we print it out, it'll say Darth Vader with several question marks after it. Honestly, that's the same as just doing this. Just depends on how you like to do it, right? s.concat with some question marks, or just add some question marks, concatenate them to the end of it like that. How about compare to? What does that do? Compare to x will be 0 if they match. X will be negative if the string is less than, in other words, alphabetically before S, and X will be positive if the search string is greater than, higher in the alphabet. So if we just print out S, it's probably going to be negative because Bob is lower alphabetically than Darth. There's also a compare to ignore case if you want, which is a good idea when you're doing mixed case comparisons, because uppercase B and lowercase b are not the same. So when we try to compare them, anyway, so system.out.println compare to returned plus x. See what it does. Should be negative if my prediction was correct. Compare to return to 2. Alrighty, maybe I need to look more carefully what compare to really does, because that's not what I was expecting. Compares two strings lexicography. The result is a negative integer if the string object precedes the argument string. Oh, I think I just have them swapped. The result is positive if the string object follows the argument. Okay. Okay, so I should have rewritten this. X will be negative if S is less than the argument. And X will be positive if the string is greater than the argument. So let's not search Bob. Since we're comparing against Darth, we're going to compare against Luke. Luke is higher in the alphabet, so we're going to see it turn into a negative number. There we go. -8. You may be curious as to exactly what it's telling us. Like, why was it +2 and -8? Was it the distance? Yeah, like a B to a D was 2 apart, and a D to an L, if I counted them, like, you know, E, F, G, H, I, J, K, L, probably 8 characters away. So it just gives you a three-way return statement to check to see, you know, are they the same, or is it less, or is it greater than? Take a look at something else. S dot sorry, I got distracted there. Is empty. Check to see if the string is empty. Right? If S dot is empty, then print there's nothing in there. There's not, but I mean, it's not empty. And there was another one called is blank, which I've never looked at. Okay, returns true if it's only white space. So if it's empty or contains only white space, then is blank would return true. So printf, formatted output. If we want to make our output look pretty, if we want all the numbers to line up like it was in a report, and we want every number to have this correct number of places after the decimal point, and maybe we want some commas added onto it, system.out.printf controls that. So if we have a number, double D is equal to math.by, right? And let's say that we want to print out several different numbers based on that. Double D1 is equal to D times 1, double D2 is equal to D times 2, double D3 is equal to D times 3. And we want to print those out nicely. System.out.println parentheses D1. And let's just copy and paste that to make it print D2 and D3. All right. Well, great and all that, but maybe we don't want that many decimal places. And just to keep going with a point here, I'm going to make another one that says double D4 is equal to D times 4. All right, so say I wanted this to be prettier. Say I wanted it to look like it only had 5 places after the decimal point, and all the decimal points were lined up. So these numbers had to have a space in front of them in order to get that to work. Well, we can do that. We can do that with printf, system.out.printf, parentheses, quote. Now, printf, you give a format specifying string, and then you put a comma, and then you put the number or the data that you want to be printed using a format specifier. Well, since this is a floating point number, I'm going to do %f. Since I want 5 places after the decimal, I'm going to make it 0.5f. And I'm going to do that for D2, D3, and D4. Alrighty, I see a big mistake. I forgot to put \n. Printf under, unlike printl or println, printf does not go to the next line. Good step in the right direction. Still not perfect because I want the decimal points to be lined up. So I need to tell it how many spaces I want this to occupy. Our largest data here occupies 8 characters, 8 spaces. The 2 before the decimal point makes 3, and then 5 more makes 8. So if I say print out 8.5 F, then we'll see it done like that. So when we print things out, we may not care about having, huge numbers of decimal points. We may only want 2 or 3 of them, in which case it's easy to fix, right? You just do %.2f or %.3f. Let's play a little bit more. We're going to make a for loop for int I equals 0, I is less than 10, I plus plus. We're going to print out system.out.println. We're going to use printf. Since these are integers, we're going to use %d rather than %f. So %d, %d, %d. And we are going to print out I and I times 2 and I times 3 for whatever purposes. And I forgot to put my \n in there. I get so used to it doing it automatically since println does. There we go. Okay, how could we make this prettier? These are not all allocated to the same width. It looked like if I made each one assume that it was 2 columns wide plus a space, it'd be a little bit prettier. So I'm going to do %2d so that each one of them occupies 2 spaces. There we go, just like that, right? Now it's nicely lined up. Much better. I'm going to do something similar for double d equals 0, semicolon, d is less than 10, semicolon, d plus plus. We're going to print out system.out.printf parentheses %f space %f \n, and we're going to print out d and d to the power of 2 and d to the power of 3. So math.pow d to the power of 2. That's probably enough. I already have a variable named d. Okay, great. So dd is equal to 0. dd is less than 10. dd plus plus. Print out that number and then print out its squared. All right, since these are whole numbers, maybe we don't need all these decimal places. We could do %.0f, right? And let's go ahead and do the cubed as well, but we're going to have to space things out a little bit more. So I need one more %f there, right? %f, 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 and I'm printing out dd, and I'm printing out math.pow dd, comma 2, and then I'm going to print out math.pow dd 3. All right. And let's leave at least one decimal point, just because it's kind of cute to see the decimal points. And then the largest one we want to see is 1, 2, 3, 4, 5 characters wide. So I'm going to make it %5.1f. %5, meaning it needs to be 5 characters wide. Pad it with spaces if you need. .1, meaning one space after the decimal. 5.1, 5.1. All right, they're lined up. And let's make it .0f. We don't need to see those decimal places. They're all whole numbers. So like that. All right, there we go. Hope that makes sense. I think we've talked about it before, but with printf, you have several different choices. %s is a string. %d is a decimal number, an integer, base 10. %f is floating point. %x is to print out a hexadecimal integer. You almost never need that, so I'm only not even sure why I'm listing it. And I believe that %e is an exponent format. So we do this, system.out.printf, parentheses, quote, number equals %e, \n, end quote, comma, and now let's just pick some number to type in, right? 444.5555. See what that looks like as an exponent. It'll be 4.4455 and show the rest of the exponent. There we go. So when you're using printf, the digit, the number after the %sign, if any, specifies the total width. It will be padded out to that width. So if you do printf %10d, and the number 300, it would print out 7 spaces followed by the number 300. You would get, oh heck, why don't we just actually print it? System.out.printf %10d \ln. All right. So it's going to have 7 spaces in front of it, followed by the 3 and the 0, 0. Like that. I'm going to change this up just a little bit. Number is %10d exclamation mark. Like that. There we go. What if we want it to be left justified? We can make it left justified. Right now it's right justified. What do I mean by right justified? If I change this up and I print 3000, right, then it's only going to have 6 spaces preceding it. The numbers are lined up according to the right margin. So it's right justified by default. But we can make it left justified if we want, in which case the spaces will come after the numbers rather than before. So if I copy these two values, these two print statements, and make it say % minus, the minus means left justify. Put a minus after the percent to left justify the padding. And there we go, right? So this had 7 spaces appended to it, and this had 6 spaces appended to it. If using a floating point, use a decimal followed by the number of digits you want displayed. So percent dot 2f with pi would print out 3.14. System.out.println %.2f \n end quote comma math.pi. I made it println even as I said printf, I believe. So I'm printing it out with %4, %6, %.6, %.2, %.4, %.6. And then with no limits, right? Well, first, let's make this %.0. We'll see no decimal places there at all. And here, if we get rid of the dot entirely, if it's just %f, it'll display the full contents of it. And when I say full contents, it's not the full contents of it. Rounds it off to 6. So if you use %f, it displays by default up to 6 decimal places. But we know that pi is a lot longer than that. So we could have done %.12f, and we'll see it out, to 12 decimal places. Like that. What if you're just printing out 0 and you don't specify a number of decimal places? He didn't like the fact that I passed in an integer. Okay, fine. 0.0. See, %f wants a floating point number, and I passed in 0, which is an integer, and it didn't feel like doing the conversion. So it crashed, so I fixed it, I run it, and there we go. So when printing, %f for floating point, a default of 6 places after the decimal will be used. You want to change that, then do the %. I'm not even sure how to word that. Anyways, to change that, use the %decimal specifier like we show above. So percent, it indicates the beginning of our placeholder. %.2f would be a floating point number with 2 places after the decimal point. The first thing after the percent sign are the flags, like the minus to left justify it rather than right. Then you can have the width, and then the dot precision if it's decimal point, and then the conversion character. For the format specifiers, we can have several different kinds: string, decimal, a float, an exponent. All right, I think that's about enough. We are done with the chapter. Oh, I guess the flags that you can use. I talked about using the minus sign to do the left justification. But if you want to pad it out with zeros, with leading zeros rather than spaces, you can do that. System.out.print F. We're going to print out this number, but we want a whole bunch of leading zeros. So %0 9D \n, and I'm going to print the number 700 out, but it's going to have, or 789, it's going to have leading zeros. Right? So this here means padded out. The leading spaces would instead be replaced with zeros. This indicates the total width. So until this number is 9 digits wide, add zeros to the beginning of it. And then what if you want to see commas, like, 1,233,000, right? If you like numbers to be printed out like that, you can do that as well. You just put that before the width specifier. System.out.printf parentheses quote %, D \n and 1. There. Some cute little number to print out. Is that like 40 million or something like that? Prints it out with our commas. So if we have some price that we have just calculated, double price is equal to and we want to make it look nice in dollars and cents and commas, system.out.println parentheses printf, parentheses quote, the price is $, and now here's our format specifier. We're going to use %f because it's a floating point number. We want 2 places after the decimal point, just like dollars and cents, ... So %.2f. But we also want those commas there to make it look awesome. So %.2f \n, end quote, comma price. End parentheses, semicolon. And there we go, right? Showing out 3 million. So add another 0 to that just to make it more fun to look at. There we go. That'll be 30 million. And so on, right? You like seeing commas in your numbers? Well, I guess if the number is very long, it helps break it up, right? Your eye can visually break it up. Alrighty, I'm not going to create a homework assignment at this time for this particular one. We're going to have one more lecture this week. We've already done the graphical user interface one, which I just posted. Excuse me. I'm going to have you watch this one, and then we'll start on Chapter 6. And so the Chapter 6 lecture will be posted Wednesday or Thursday.